today's presentation, we're going to take a look at fraction review number 1. And we'll look at 3 fraction word problems. And here is the first. Margaret has 2 1/3 cups of sugar. She is using 1 1/4 cups to make cookies. How much sugar will she have left? So you take a look at this question here, and within that question is our math job. It tells us what we have to do. So we have to find out how much sugar that she will have left. I'm thinking about that word left there. How much she'll have left. Kind of hints that we're going to be taking something away. So let's go through it sentence by sentence, looking for math clues. First sentence, Margaret has 2 1/3 cups of sugar. So 2 1/3 cups sugar. Okay, that's probably pretty important, that mixed number. And second sentence, she is using, so we're using 1 1/4 cups to make cookies. So that shows us that we're kind of looking at how much she's going to use. So now we're working with these 2 mixed numbers. We've got 2 1/3 cups of sugar, and she's going to use 1 1/4 cup of sugar to make cookies. So let's take a look. We've got this clue down here. How much will she have left? So like I said, kind of hint that we're going to be taking something away here. So let's set it up down below, and hopefully you're thinking about what operation you're going to be using here. We've got 2 1/3, and we're also working with 1 1/4. Hopefully you were thinking it would be subtraction, and if you were, you are exactly right. So it's subtraction. She starts with 2 1/3 cups of sugar, and she's going to take away 1 1/4 cups to make the cookies. So how much will she have left? Well, we have to figure this out. Well, you could subtract these whole numbers. Yeah, you could do that, but we've got to really deal with these fractions first. And with all the practice we've had with fractions, we've got to look at these denominators. I bet you were doing that too. Good for you. So we've got 3 and 4. So these denominators are not the same. So can we subtract them now? No way. We have to figure out how to change these so they have the same denominator. So a lot of times we looked at the LCM method. So let's jot that down here. We've got LCM, lowest common multiple. And when you're doing that, you've really got to look at the denominators. So we've got 3 and 4. So I'm going to look at 3. I'm going to look at 4. And I'm going to find the multiples of those. And once I do that, I can look at to see which is the lowest common multiple. So if you start with 3 times 1, you get 3. Whoa, that doesn't look like an equal symbol or equal sign. It wouldn't be an equation without one, so let me rewrite that. So 3 times 1 equals 3. 3 times 2 equals 6. And 3 times 3 equals 9. I'll try one more. Maybe you're looking ahead and thinking ahead, I should say. Oh, there's that equal sign again. We'll just leave it for now. So just know that's an equal sign. It's got 3 times 4 equals 12. And now we'll do the multiples of 4. You might be thinking to yourself, oh, Mr. Murdoch, I know it already. And if you do, hey, nice job. But we'll just keep doing the multiples for 4. And we've talked about how that's skip counting. By 4, you can see 4, 8, and for 3, we had multiples of 3, 3, 6, 9, 12. Also skip counting, but that time by 3. So now we've got 4 times 3 equals 12. Wow, well, there you go. You can see that we have a common multiple right there. that 12 is a multiple of 3, and 12 is a multiple of 4. So 12 would be our LCM. So LCM equals 12. And once you have your LCM, your lowest common multiple, you've got yourself a new denominator to work with. So I'm just talking about these fractions right now. We're going to leave the whole numbers the same. And we can do that for this problem. So we'll just rewrite the fraction part of that mixed number. Just know that it all goes together with a denominator of 12. Our LCM will be 12. So we've got a new denominator of 12. And we have to change them. So how can we convert fourths into 12s? Well, you think to yourself, 4 times what equals 12? And let me just switch my pen while you're thinking about that. Hopefully you're thinking 3. There we go. Because 4 times 3 equals 12. What you do to the denominator, you have to do to the numerator. So numerator times 3 would be 1 times 3, 3. Now we do the same type of thing to our denominator up here. So we go 3 times what equals 12. And you probably showed your work over here. 3 times 4 equals 12. So that helps you to show your work. Kind of proves you know what you're doing too. We'll do the same thing to the numerator. So 1 times 4 equals 4. 4 twelfths. We just made another equivalent fraction for 1/3. 1/3 equals 4 twelfths, by the way. We multiplied by 4 over 4. Gives us an equivalent fraction. So now we can work with these fractions. If you'll notice, let me try to rewrite that. That'll just disappear here. Okay, now let's try that magic pen again. And you've got 4 twelfths, and our original symbol was subtraction because we were taking away some sugar out of the original amount we had. So 4 twelfths minus 3 twelfths, and you're probably thinking to yourself, no problem, because you now have the same denominator for that. So we can deal with that. So we've got 4 twelfths minus 3 twelfths equals how many twelfths? 4 minus 3 equals 1. So now we can deal with these whole numbers, and we've got 2 minus 1 would equal 1. And there you have your answer. There's the first method of solving that problem. So let's check to make sure we answer the question. How much sugar will she have left? Margaret will have left 1. And let's just write that down here. Let's move our work out of the way a little bit. And she will have you could have put Margaret. She will have 1 1/12 cup left. And that would be cups of sugar. So there you go. There's the first solution to that problem. Not so bad. And now we're going to show, let's look at the array method for solving this problem. All right, so we still have the same mixed numbers we're dealing with. We have 2 1/3. 2 1/3 minus, I believe it was a 1 1/4. Let's double check. 1 1/4. Yep. 1 1/4. We'll check that out. And you could write it, horizontally too. You could have 2 1/3 minus 1 1/4. This 2 should be a little bit bigger. I should have written it bigger, but you could set it up that way. and then solve it. Now, with an array, I'm just going to take a look at the fractional part of these. So we've got the 1/3 and the 1/4 we're dealing with. The whole numbers we could easily subtract at this point. Just leave that for now. So now we're looking at 1/3 minus 1/4. And we can show that with an array simply by making a 3 by 4 array, and our denominators tell us that we can do that. So let's do 1, 2, 3 by 1, 2, well, there's 2, 3, 4. That could be just a quick sketch of an array. It doesn't have to be anything fancy, but just kind of a quick sketch of it. So I'm going to copy that and paste it over here. So now we've got 2 arrays kind of representing each of these fractions. So with 1/3, our denominator, the 3, I'll switch colors, the 3 here, tells us we need to look at groups of 3. You can do it this way. There's another group of 3, and a last group of 3. And our numerator comes into play here. We've got 1 out of 3, so we have to show 1 out of 3 in each of these groups. So we've got 1/3 here, 1 out of 3 there, 1 out of 3 there, and the last 1/3 there. And we've got a new fraction now. How many parts make up this array? Well, we've got 3 times 4 would be 12 dots make up that array, and we really looked at 4 out of 12. You can see the similarities from what we did up here. And we ended up with, we changed 1/3 to 4/12. This is just showing your work with an array. And now we'll look at 1/4. And our denominator is 4, so that tells us to look at, I bet you guessed it, groups of 4. And our array is organized here. We've got a group of 4 here, a group of 4 there, and a group of 4 there. And our numerator is a 1 in this case as well. So we're going to do 1 out of 4 in each of these groups of 4. So we've got 1 out of 4, 1 out of 4, 1 out of 4, 1/4, 1/4, and 1/4. So if you put it all together, you've got 12 parts of your array, and 3 of those we focused upon here. So we looked at 1/4 3 different times, and we end up with 3 of those, but it's out of 12 now. So we've got a common denominator. That's just another way to come up with a common denominator. And now we can easily subtract these two. Denominators stay the same when you're adding or subtracting, if they're the same to start with. And then you just subtract 4 minus 3. And you get 1/12. And there you go. You're almost done with that. That was pretty quick. So now, instead of 2 and 1/3 and 1 and 1/4, we've already dealt with that subtraction of the fraction part of it. So we've got 1/12. Actually, I should write it up here. 1/12. And it was 2 minus 1 would be 1. And there you have that same answer that we got before. 1 and 1/12. And that would be cups of sugar she has left. Margaret had 2 and 1/3 cups to start with. She used 1 and 1/4, came up with 1 and 1/12 cups left. And there you go. There's the answer to the first problem. And here's problem number 2. We've got, here it goes. Kristen has 1/3 yards of fabric. She needs to divide the fabric into 3 even pieces. How big will each piece be? So automatically, you're probably looking at that question. Good for you. So how big will each piece be? So we're looking at each piece here. Each piece. How big will each piece be? And we'll jump back up to the first sentence and start looking at clues. Kristen has 1/3 yards of fabric. So she's got 1/3. Oops. get this out of the way. 1/3 yards of fabric. So 1/3 yards fabric. She needs to divide. Oh, look at that. Divide. That sounds pretty important. That sounds like a big clue for you. Divide the fabric into 3 even pieces. So in this case, we've got 3, the number we're looking at, and then even. Hoping you probably realize that even means equal in this case. So 3 equal pieces, 3 even pieces. So 1/3 divided into 3 even pieces. Wonder what operation we do here. I bet you know. I bet you're thinking that it is division with that big clue there. And also, if it didn't say divide, it could have said she needs to cut the fabric into 3 even pieces, so it's like equal groups. So we've got, all right, got 1/3 that we started with. So you have to put that first when you're talking about division, because you can't switch around the dividend and the divisor. You just have to keep them in order, or else you're going to get a different answer, and it would be not the correct answer in this case. So we've got 1/3, and we want to divide it into 3 equal pieces. So you could say, 1/3 divided by 3. Now the traditional method would tell you, of course, that you've got 1/3. And you know, in other posts, we've proved that if you switch the operation from division to multiplication, you know, that's the inverse operation. So you're going to take the flip of this number here. So it was, if you looked at it as 3/1, and maybe I should write that. Yeah, let's do that. So if you're, you know, you're showing your work, you really want to be accurate. So I'm going to do that. I move that down. If you're working at home and you're writing with pencil, you can pause it. Pause the video and then kind of fix that. All right, so now we've got 1/3 divided by 3. Well, 3/1 is the same as 3, because if you look at it, every fraction is a division problem. You could say 3 divided by 1 still equals 3, right? So now with fractions, it's easier to deal with two fractions. So now we'll say the inverse of division is multiplication. So in this case, we have to take the second fraction and flip it. They call that the reciprocal in math. And now we can multiply. And when you multiply, you can simply multiply numerator by numerator and denominator by denominator. So you have 1 times 1 is 1, and 3 times 3 is 9. So how big will each piece be? So we started off with 1/3 yards of fabric, and each piece would be, so let's write that down. We've got each piece will be 1/9 of a yard. There you go. So that's the traditional method that, you know, the method I was originally learned when I went through school. Nothing wrong with that. It served me okay, served me just fine. But now we know we can show our work in different ways. We did array method for that previous subtraction problem. So let's take a look at the pictorial method. So we started off with 1/3. So I'm going to show that as 1/3 of a whole. Whoa. Let's make that a little more neat. All right, so we've got, that's a little bit better. Okay, so we've got 1/3. We divide it into 3 equal parts. So we started, okay, so I'm going to divide that into 3 equal parts, that whole, and I'm going to shade in 1 out of the 3 parts. See that? When you're doing a fraction or math drawing, it doesn't always have to be perfect unless you're asked to do so. It's really just trying to show your ideas here. And now we have to divide it into 3 equal parts. So you've got that 1/3. And we're going to now divide the whole into 3 equal parts. It's kind of subdividing here. So now you got, okay, so we've broken up that third into 3 equal parts, and each, let's see, each piece of that ribbon would be, is that what it says? How big would each piece be? Okay, it's always good to go back and check your job in the question there and see if you're on the right track. So I think we are. We are. So we've got 1/3, but we had to divide into that into 3. So now we've got a new denominator because we broke the whole up again by 3. So we have 9 equal parts. As you can see, that the pictorial method is nice for this. You can just see it. You know, it's pretty good. But really, we started with 1/3, and we've got 3 equal parts, and we're really focusing upon one of those. So let's kind of zero in on that. Let's see. Hopefully we can change the color here. Whoops. All right. So now we're looking at just that section there. Okay. This section right there is kind of nice. It expands it for you. Look at that. Ooh, pretty good, huh? Now, kind of jumps out at you. But it's really this section up here you're looking at. And another way you can highlight it is to, I can just use a different color here. So there would be 1/9. And that would be the answer again. And it's the same as the traditional method up here. We ended up with 1/9. And this pictorial method kind of shows that we were on the right track. So there we go. Each piece will be 1/9 of a yard. And that's the answer to the second problem. And now we'll take a look at the third problem in our fraction review number 1. And we've got Tessa is baking blueberry pies to sell at her bakery. She starts with 3 1/2 cartons of blueberries, of which she uses 1/2 for the first batch of pies. How many cartons of blueberries does Tessa use for the first batch of pies? There you go. There's our question. How many cartons of blueberries does Tessa use for the first batch of pies? Ooh, kind of erase some of that kind of overlapped a little bit. So it's asking us how much did she use for the first batch of pies. Let's go through sentence by sentence. Now, okay, she's baking blueberry pies to sell at her bakery. Story information, not much math to deal with there, none really. So now, second sentence, she starts with 3 1/2 cartons of blueberries, of which she uses 1/2 for the first batch. Okay, 1/2 for first batch of pies. Okay, so now we're dealing with this. We've got a mixed number in 3 1/2, and we have fraction 1/2. So she starts with 3 1/2 cartons of blueberries, and she uses 1/2 of those. So I hope you're starting to see what we're heading towards here. 1/2 of 3 1/2 cartons of blueberries. So this 1/2 represents the first batch of pies that she made. Okay, so now hopefully you'd have seen enough of these at this point that you're probably thinking multiply. Well, exactly correct. You'd be so right. So we've got 1/2 times 3 1/2. So how are we going to multiply this fraction by the mixed number? Well, I think we're going to stick with the array method for this one. So let's check it out here before we do that traditional method. We'll take a look. We'll draw some pies here. And usually pies kind of look like circles, so we'll use circles. There's one. We move it around a little bit. So you can, as I'm working on this, I'm going to just work on, whoops. I'm going to work on making 3.5 pies. Okay, so in order to do that, I really want to show 4 pies because 3.5 requires you to have 4 pies to start with. Or, I'm sorry, I'm talking about the wrong thing. That's why it's always good to look back. So we've got 3.5 cartons of blueberries. So really those aren't pies, my mistake. So I'm going to keep the cartons round since I started to work with those. It really could be any shape. So I'm going to show 3.5 on these pies. So there I go again. 3.5 on these cartons. So now I'm going to divide that one in half and shade that in. Alright, so there's the blue to represent the blueberries in these cartons. There's the half carton. I'll talk about the whole numbers here. So I'm going to shade these in. Again, math drawings don't have to be perfect. So we've got 3.5 shown here. Now we have to get 1/2 of 3.5. So how are we going to do that? Okay, well, I know what I can do. I've got 1/2 of 3.5. Let's see, let's try dividing that down this way. So 1/2 of 1/2 there would be, okay, 1/2 of this pie would be one section here. Let me just backtrack a little bit there. I'm going to divide each of these in half because, you know, it's 1/2 of 3.5. So I can just take 1/2 of each of these. And then, because that's what my denominator tells me to do, and I'm going to look at shading in and using a different color. So 1/2 of this pie, carton of blueberries would be here. That would be 1/2. There would be a half. And there would be a half. And now, looking at this half of that half of the carton of blueberries. So now, I'm looking at, okay, so I've got 1/2, you know, 3 times, 1/2, 1/2. And now what am I going to do here? Oh boy, I've got 1, but it's not a half, it's a 1/4. So now we've got 1/2 plus 1/2 plus 1/2. And if you took this half and put it here, that would make 1 pie. So we've got, all right, so that's a 1. And now we're dealing with this half. Right here. So again, so if you took these 2 halves and put them together, it would equal 1 whole pie. That leaves you with this half we're still dealing with, and this 1/4 of a pie. So now we have to add these two together. 1/4 plus 1/2, and you know, visually you could probably see this. So in order to add fractions, you have to have the same denominator. So in order to make the same denominator, I just divided this one in half again. So now I've got 4 parts in this hole and 4 parts in that hole, and now we can add these up. So this half would also be equal to 2/4. And this over here, this quarter, well, it kind of stays the same when you're adding it. It's still equal to 1/4. And we have the same denominators now, so we can just simply add those. So 2 plus 1 would be 3. And our denominator stays the same. We got 3/4. So the answer is 1 3/4. Let's see if we can answer that question now. How many cartons of blueberries does Tessa use for the first batch of pies? She used 1 3/4 because 1/2 of 3 1/2. We proved that to be 1 3/4. There's the answer down there. So let's write our answer. Okay. Tessa used 1 3/4 cartons of blueberries. Now, we've solved that with the pictorial method. Let's take a look at solving it with the traditional method. You have to do something a little different though. So 1/2 times 3 1/2. Let's check that out. Divide our workspace up. And we'll rewrite the problem. 1/2 times 3. What was that? 3 1/2. 1/2 times 3 1/2. How do you do that? You got a mixed number here. Well, fortunately for us, we did the pictorial method up above. So you can see that 3 1/2 would be, oops, 3 1/2 would be 1, 2, 3, 4, 5, 6, and 7 halves we started with up there. So you can change this 3 1/2 to 7 halves. And then multiply it by 1/2. And with multiplication, you could switch these two around. You could have 7 halves first by 1/2, or you could have 1/2 times 7 1/2. It's just like when you have 3 times 4 equals 12, and you switch them around, 4 times 3 equals 12. So multiplication, in addition, you can do that. Not division or subtraction, though. So we've got, now we can multiply 1 times 7 would be 7. And then multiply the denominators. 2 times 2 would be 4. And if you look at this answer, 7/4, so then it's an improper fraction. So with that improper fraction, you can simply look at it as a division problem. We've got 7 divided by 4. So 4 goes into 7. How many times? 4 times 2 would be 8. So 4 times 1 would have to fit the best. So 1 times 4 would equal 4. Subtract. And you get 3. All right. So that's your kind of like your remainder. So we've got, it fit in one whole time, and then your divisor over here becomes your denominator, and your remainder becomes your numerator. So it's 1 3/4. And look at that. It's the same answer. We have 1 3/4 and 1 3/4. I did have to convert this mixed number into an improper fraction so we could multiply. But luckily, we had the pictorial method to show it. So we had 3 1/2 to start with. And you can see that it would be 1, 2, 3, 4, 5, 6, 7 halves originally. And that was why we could use 7 halves as our mixed number. We multiplied, got 7/4, and we came up with 1 3/4 as the number of cartons used by Tessa in that first batch. Oh, forgot my period on there. Tessa used 1 3/4 cartons of blueberries. And there you go. Thanks for checking out Mr. Marinek's EduBlog, and we'll see you again next time.